Imagine evolution as a staircase. At the bottom is lifeless chemistry. At the top is a civilization capable of spreading across the galaxy. Earth has climbed from simple molecules to intelligent beings who can build rockets, split atoms, and search the stars. But when we look into space, every other staircase appears empty. More than 6,300 planets have now been confirmed beyond our solar system. The Milky Way contains billions more. Yet we have found no verified signal, no alien megastructure, and no civilization expanding between the stars. That silence matters because a civilization would not need faster than light travel to become visible. It could move gradually from star to star, launching new missions from every settlement. Even a journey lasting millions of years would be brief compared with the billions of years available in our galaxy. If technological civilizations commonly survived and expanded, some trace of them might already be difficult to miss. So perhaps somewhere on that staircase is a step that almost nobody survives. It is called the Great Filter. The idea was developed by Robin Hanson as one possible answer to the Fermi paradox. It is not a proven law of nature. It is a warning hidden inside the silence. For dead matter to become a spacefaring civilization, it must pass through an extraordinary chain of events. A stable planet must form in the right environment. Chemistry must organize into self-replicating life. Simple cells must become complex. Complex life must become multicellular. Intelligence, language, technology, and cooperation must emerge. Finally, that civilization must survive long enough to leave its home world and expand. If even one of those steps is almost impossible, the galaxy could contain countless planets while remaining almost completely silent. And the filter may not be one dramatic wall. Several individually difficult transitions could combine until the probability of completing the entire journey becomes vanishingly small. The hopeful possibility is that the filter is behind us. Perhaps the origin of life is unbelievably rare. Maybe simple cells appear occasionally, but complex cells almost never evolve. On Earth, microbial life existed for billions of years before complex organisms transformed the planet. Intelligence capable of building technology appeared only once that we know of. If one of those ancient transitions was the Great Filter, humanity may already have passed the hardest test. We could be among the first civilizations with a genuine chance to reach the stars. But there is a darker possibility. What if life and intelligence are common, and advanced civilizations repeatedly disappear before becoming interplanetary? Technology gives a species extraordinary power before it guarantees extraordinary wisdom. Nuclear weapons, engineered pandemics, uncontrolled artificial intelligence, ecological collapse, or conflicts over resources could become future barriers. These are possibilities, not predictions. But a civilization only needs to fail once to erase centuries of progress. That is why discovering life elsewhere would carry a strange message. Finding simple microbes on Mars, Europa, or Enceladus would prove that life can begin twice within one solar system. That would be one of the greatest discoveries in history. Yet inside the Great Filter hypothesis, it could suggest that the origin of life is not the rare step. Finding complex or technological life would push the mystery even further forward. The more easy steps we discover behind us, the more we must wonder whether the hardest step is still ahead. So how could humanity improve its odds? There is no single escape plan. Becoming multi-planetary would not make us invincible, but it could protect civilization from disasters limited to one world. Independent settlements, protected knowledge, diverse energy systems, planetary defense, responsible technology, and cooperation across generations could create layers of resilience. The goal is not merely to plant a flag on Mars. It is to build a civilization capable of surviving mistakes, adapting to new worlds, and preserving life across deep time. Perhaps the silence of the universe means we are exceptionally lucky. Perhaps it means the real test has not begun. Either way, humanity is approaching a point where its future may no longer be decided by biology alone, but by the choices it makes. The Great Filter may be behind us. It may be waiting ahead, and the first cosmic civilization could be the one that finally learns how to pass through. This is Cosmic Civilizations. Subscribe and continue with us on the road to a cosmic civilization.